Hi guys, it's still Mr. Richard. Hope you're well. This is our video 3 of MIP 1502. So I will start with question 2.1. What are variables? Right? In the simplest term, what we can say, remember we're still on question, this is question 2. So we're making 2.1 there. Specifically, variables are usually letters. Are usually letters. They are usually letters. They're usually letters, or we can say other symbols that represent unknown values, yes, or unknown number, unknown values. So those are the variables, right? Then let's go to 2.2. For what purpose are variable used? Mention 3 and justify your answer. Justify your explanation by examples. Well, variables are mainly used in mathematics for solving problems, more especially in algebra. 2, in mathematical modeling. 3, in a graphical form. You can think of many. 4, in shopping problems. 5, you can think of in speed and distance. You can use variables. Therefore, let's put this into practice. Remember that I told you it's now we're at 2.2, right? They said for what purpose? They can be used in algebraic expression. They can be used in algebraic expressions, right? E.g., when you are solving an equation, x plus 9 is equals to 4. So we can use variables. Also, they can be used in weight problems. E.g., maybe let's say SIPO is 10 years older than his brother. This is an example. Okay. Hope you see my ugly writing. In 5 years time, SIPO will be twice as Tabo. So how old is Tabo? How old is Tabo? This is a problem. Then what you could do when you're working with such, for e.g. the example, since in terms of variable, we will let T for Tabo will be x, and we will let SIPO, which will be x plus 10. You will then solve this equation, right? So now let's focus on the third one. The third one, maybe we can use variables in graphs. E.g., for example, in graphs like y is equals to x plus 4, where y is a independent variable, and where x is where y is a dependent and where x is an independent, and 4 it's a y-intercept, or we can say a constant value, right? So that's where you can use those are the purposes of using a variable, is that it's for unknown terms or unknown values in a given problem. Yes, so that's where we can use variables. Now we are going to work with 2.3. At 2.3, answer the following question based on your understanding of variables. Give an example of how a visual image can be used. Okay, that is 2.3.1. Okay, let's put this into practice. 2.3.1. Let me say I draw a square, divide it into 4, then I color. Some can use a circle, it's fine. It's a visual image, so can be used as a variable. So in this case, I can say 1/4, right? Given an example of how a visual image can be used as a variable, then that will be my answer. You can also come up with your own answer, right? So we go to the second one. What is the mathematical convention about the use of letters, variables in algebra? So let's answer that now. Right, to answer 2.3.2, your answer will be like, we can use variables such as x and y and z. Yes, as letters in algebra. Yes, that's how you can answer 2.3.2. Yes, let's go to 2.3 now. Okay, at 2.2.3, how will you avoid confusion between the meaning of m, for example, as a variable, and m as a measurement when using 5 meter in an expression? What you can answer 2.2.3, you can answer 2.3.3 by saying the other m will be for a variable, and the other m, the smaller m, will be for units. Yes, the other m will be actually they are saying, how will you avoid confusion between the meaning of m, for example, as a variable, and m a measurement, until when using 5 meter. So to prevent that confusion, I can use the other m in capital letter and the other m in small letter. The one that in small letter will be my unit, and the one with in capital letter will be my variable. Hope I make it clear. That's how I can answer that question. Right, then let's go to 2.3.4. How will you ensure that variable x is not confused with a multiplication sign? How will you ensure that the variable is not x is not confused with the operational sign x for multiplication? Let's see how can we put that into practice. To ensure 2.3.4, this is what we should note. The symbols are not the same. For multiplication, it's like this, and for x, it's like this. But we can ensure that by showing that the multiplication we differentiate that by brackets. Yes, brackets of multiplication. That's how I can differentiate here. Guys, hear me well here. 2.3.4, you also have your own opinion. That it doesn't mean that mine is correct. Even yours, it's suitable. Anyone can come up with his or her solution. Now let's move to 2.3.4. There are 3 containers of marbles: container, marble P, and container Q, and container R. Container Q has 2 marbles than container P, and container R has 4 times as many as container P. The total number of marbles in all 3 containers is 14. So at 2.4.1, use x to represent the number of marbles in container P and write the equations. that describe the rules above, then find the number of marbles in each container. Right, so let's put this into practice. To answer 2.4.1, let's collect the data. They said container P, they said there's container P, Q, and R, right? And we are told that in container P, we are not told what is how many marbles do we have, but we are told that at Q has two more than has two more marbles than P. So in other words, it has 2 plus P, right? And we're being told that R has 4 times as many as marbles as container P. That will be 4 times P, right? So the total in all 3 containers is 14. So they said use X. So in terms of X, let P be X and Q be 2 plus X, and let R be 4 times X. So in this case, we are going to sum up them since we have a total there. We're going to say X plus 2 plus X there plus 4X, which is equated to 14. Let's collect the variables there. Remember, I said X plus 2, X plus X, that will be 2X, right? Plus 4X, that will be 6X. Transpose 2 to the other side, it will be 14 subtracted by 2. Yes, these are constant and a constant, a variable and a variable. 14 separated by 2, that will be 12. So how many times does the 6 goes into 12? It goes 2 times. X is equals to 2. So what will be P? P will be 2. We'll have 2 marbles. How many marbles at Q? We are going to have 4. So we are going to say 2 plus 2, which will be 4. How many marbles are we going to have in R? Where there is X, put 2 there. 4 times 2, we are going to have 8 marbles. Guess we have answered 2.4.1. Let's go to 2.4.2. They said use Y to represent the number of marbles in container Q. Okay, container Q, you may recall that it was 2 plus X, right? And remember, we saw that there are 4 marbles, right? So they want us to represent this in terms of Y. So where there is X, let's replace by Y. Take 2 to the other side. It will be 4 minus 2, which is equals to Y. If we can add by 8, it will be very tedious because it will be 2 plus Y, which will be 10. Then when we want to make Y the subject or solve for Y, it will be negative 6, in which it's incorrect. We cannot have a negative variable in this case. So it will be 4 minus 2. This is the correct way. 4 minus 2, this will be Y is equals to 2, right? So, all right. Then they said use Y. Yes, 3 marks. Okay. So that's how we can work out with that. Then let's go to 2.4.3. Use Z to represent the number of marbles in container R and write equations that describe the rules above. Then find the number of marbles in each container. Okay. So to make things simpler, okay. All right. What we can do here, they said find the number of marbles. Okay. We know that for container R, it was 4 times X. Then what did we get there? For container R, it was 8. Then let's replace, where there is X, let's replace by Z. Divide both sides by 2. We are going to get 2. Yes, because 4 goes 2 times here. So in other words, we have 2. In terms of Z, it will be 2, right? So that's how we can work out such problem. Right. Don't forget to comment if there are things that you need clarification on. Thank you for watching, and don't forget to subscribe. You only subscribe once, guys. You don't subscribe twice. If you're new to this channel, press the red button and subscribe, and don't forget to share. We love you.